how we previously talked about getting the area between a function and the x-axis. Now we want to be able to get the area between two functions. If you have a function f that's greater than or equal to g over an interval, then if you want the area bounded by f and g over the interval ab, it's just going to be the integral of from a to b of f of x minus g of x. So all we're doing is if f is the function that's greater than g, that just means all the y values are larger than the y values of g, then you're just going to set up the definite integral from a to b, take the upper function, f of x minus g of x, and that's going to give you the area that's bound between them that we have in this picture. Now, this also helps us understand why when we had a function before that had part of the graph below the x-axis from a to b, let's say this is where it was crossing the x-axis, if we were looking for this area, we can now think of this as the area between two functions. The top function would be the x-axis, which is y equals 0, and then the bottom one is just y equal f of x. So if we wanted the area between these two functions, we would have the integral from a to b, the top function, which is 0, minus the bottom function, which is f of x. And that is what we did when we were getting the area when it was below the x-axis. We were putting that extra negative in there so that we were turning those y values positive. So you don't have to worry about putting the minus sign in there for when it's below the x-axis. If you always use the equation for the x-axis and take that to be the upper function and just subtract the lower function from it. Okay, so the main thing here is you're going to have to get a graph. If you don't have a graph, you're not going to know which function is greater and know where it might change. So first thing to do is graph the equations. So hopefully you recognize this is a line. The y-intercept is 3, and the slope of it is 1/2. So to get a quick graph here, y-intercept is 3. Right here, slope 1/2, so for every 1 we go up, we go to the right 2, or for every 1 we go down, we go to the left 2. So there's the line y equal 1/2 x plus 3. And the other one, y equal negative x squared plus 1. This is just a parabola. If you look at y equal minus x squared, that's the parabola that's going down like this with the vertex at the origin. But now if you add 1 to it, all you're doing is you're going to raise it all by 1 coordinate. So the y value then would, the vertex, it would be here at 0, 1, and it's opening downward because of the minus in front of the x squared. And I know the x-intercepts are also at 1 and negative 1. Okay, so that's the graph of y equal minus x squared plus 1. Okay, now we want to also look at the two x values, x equal minus 2, which is the vertical line right here, and x equal to 1, which is a vertical line right here. So we're looking at from minus 2 to 1 are the x values that our area is all between. And now this function down here, I haven't drawn it further, but it will come down and go ahead and meet. So the area that we're looking for then would be all this area. The area trapped between those two functions. We're looking for all this down in here to here. Okay? So now, once you see the picture, the first thing you want to see is which function is the greatest, which one is above, and is it the same one for the whole interval from minus 2 to 1. And if you notice, starting at minus 2, the line is above, and coming all the way up until we get to where the x is 1, the line is still above the parabola. So when we set this area up, we're going to have the area is going to be the integral. The x values that the area is trapped between is negative 2 to 1, and the upper function is the 1/2 x plus 3. We're going to take that one and we're going to subtract the parabola since it's the lower function, it has the smaller y values. This integral will give us what that area is. So now simplifying, this is just going to be, I'm going to go ahead and remove my parentheses on the second part. I'll have a plus x squared, a minus 1. So when I simplify, I'll get x squared plus 1/2 x, and then I'll have the 3 minus that 1, so I'll have a plus 2. And we're going from minus 2 to 1. Okay, we still haven't integrated yet, which is just finding the antiderivative. So the antiderivative for this function will be 1/3 x cubed plus 1/2 x squared over 2, so that's going to be a plus 1/4 x squared, and then plus 2x. And we want to evaluate that from -2 to 1. So now, putting in 1 for all the x's, we're going to have 1/3 times 1. So we'll have 1/3 plus 1/4 plus 2. So that's what we get evaluating it at 1. And then minus what we get when we evaluate it at -2. So we're going to have 1/3 times -2 cubed. So we're going to have -8/3. -2 squared is +4, so we're going to have plus 1 and then minus a 4. Okay, simplifying, I'm going to go ahead and remove parentheses before I try to get any common denominators. I'm going to have 1/3 plus 1/4 plus 2 plus 8/3 minus 1 plus 4. So now the 1/3 and the 8/3 together make 9/3, which is 3. And then we have the 2, so that's 5. Subtract 1 will make it 4, and then 4 more is 8. So that's going to give me 8 1/4. And that's the area. That's how many square units. If we drew little squares one by one on that graph, that's approximate area for that graph. Okay, first thing, graph it. Okay, hopefully you recognize the x squared minus 1. It's a parabola. It's going upward because the x squared has a positive coefficient. The minus 1 is telling us that it's just a standard one shifted down by 1. So it's going to start here. The vertex, if I put in x equal 1 or x equal -1, it's going to be at 0. So the x-intercepts are going to be at 1, 0 and -1, 0. So here's our parabola. And then our other equation is the line y equal 3, which is just a horizontal line. So putting a few hash marks here. 1, 2, 3. It's just going to be the line that's crossing through like that. So we have y equal 3 here. Figure out what the area is that we're referring to. So this is y equal to x squared minus 1. The area that's bound between those two functions is this part. Okay? So what we need to do is we need to figure out which function's the greatest over the whole interval where the area is at, where the area is bounded. And you can see that the line y equal 3 is always above. For the entire area here, the y equal 3 is above. So that one's going to be first minus the other one. Now we need to also figure out what the x's are that it's bound between. So we've got to figure out this x and the x over here where the area is bound between. So the way you get that is you want to know where the parabola and the line are intersecting. So find the intersection. And you could do it on your calculator by graphing the two separate equations and then use the calc to get the intersection. And you can narrow it down and get those points that way. But this is a pretty simple one. Set the two equations equal to each other. So we have x squared equal to 4, which means x is either 2 or -2. So the x and the y, the x values are -2 to 2. So now setting up our integral, which will be the area bound there. The upper function, 3, minus the lower function. Be sure you put parentheses around the second one so that it's all subtracted. The x values it's between is -2 to 2. So we've got the integral 3 minus the x squared plus a 1 when you distribute this minus sign through. So we're going to have 4 minus x squared when we simplify. And then it's still from -2 to 3. The antiderivative will be 4x minus x cubed over 3. And we want to evaluate from -2 to 2. Putting in 2, we're going to have 8 minus 8/3. Then minus putting in -2, we're going to have -8. Now -2 cubed will be a -8. It's going to be positive with the minus sign in front of it, so it'll be a plus 8/3. And before I try to do common denominators, I'm going to go ahead and remove my parentheses. You'll notice when you do that, a lot of times you can combine some things from the two different parentheses and makes it a lot simpler. Okay, so now the 2/3, that'll be 16/3, so we're going to have 16 whole minus 16/3. Now the common denominator of 3 will be 48 minus the 16 over 3, so we'll have 32/3. And that's how many square units are in that shaded area bound by those two functions. Okay, and that's just a graph and shows how it's set up there. Okay, area bounded by these two functions. Again, we've got a parabola. This time the parabola is going downward because of the minus in front of the x squared, but then it's all going to be shifted up by 5. 4, 5. So it's starting up here and it's going to go downward. Now it's going to intersect the x-axis. If you put in y equals 0, you're going to get x squared equal 5. So at the square root of 5 and minus the square root of 5. So about 2.2, 2.3, something like that. So here's where that parabola is going to look like, something like that. So this is y equal 5 minus x squared. And then we're looking at the line y equal 2 minus 2x. So the 2 minus 2x has a y-intercept of 2, and the slope is negative 2. Make it a fraction. Y-intercept of 2, slope 2, that means down 2 to the right 1, or up 2 and to the left 1. And here's the line. The area that's bound between the two would be this area right here. So now which function is the greatest? Which one's above the other? So for any given x, which one's the largest one? And you can see if you just drop the line straight through, it's going to be the parabola that you're passing through first. So the parabola is the greater one, so when we set up our integral, we're going to have the 5 minus x squared first, minus the other one. We've got to find the x values, though, that area is between, so we're going to have to figure out this intersection point and this intersection point and get what their x values are. So that's easy enough, just we're going to set the two equations equal to each other. So 5 minus x squared equal to 2 minus 2x. It's a quadratic here, so just get everything to one side. I'm going to move it to the right so that I can have my x squared turn positive. And then when you factor, you're going to get x minus 3 times x plus 1. So 3 and negative 1 are the two places. So negative 1's here where it's bound on the left, and 3 would be the x-axis, the x-coordinate of the right intersection point. So our limits then will be from minus 1 to 3. Okay, simplifying the expression here, we have the 5 first. We're going to end up subtracting the 2 from it, so we're going to have a 3 minus the x squared, and then we're going to have a plus 2x when we distribute that minus sign through. So then it's still from minus 1 to 3. So now finding the antiderivative, we're going to have 3x minus x cubed over 3 plus x squared. And we're going from negative 1 to 3. Evaluating at 3 first, we're going to have 9 minus 27 over 3 will be 9 again, plus another 9. That's what we get when we put the 3 in. Then minus what we get when we put negative 1 in, it'll be negative 3. Negative 1 cubed is negative 1, but then we're going to have another minus in front, so that'll be a plus 1/3 and then a plus 1 when we square the negative 1. So now, in the first set, we just have a 9, then we're going to have a plus 3, just distributing this minus 1 through, plus 3 minus 1/3, and then minus 1. So we're going to end up with 12 minus 1 will be 11 minus 1/3. So it'll be 10 2/3, or 32/3. Okay, so once you get the graph, it's pretty easy to set up the integral. Okay, now let's find the area bounded by these two functions between the x's of negative 2 and 3. Okay, again, this first one's a parabola. Now, it's not just a nice simple shift, though. It's got x's in both terms. So what I'm going to do is, instead of finding the vertex, I just like to factor the x out, and then I can find the x-intercepts. So when the y is 0, my x's are going to be 0 and 1. So that tells me that, let's see if I can, I know that it's going to be crossing the x-axis at 0 and 1. I know it's going up because the x squared term is positive. The vertex is going to be at x equal 1/2, and then I know it's going upward. So it's going to look something like this. And hopefully that's close enough to get what we need. The other one is y equal 2x. So 2x I know has a y-intercept of 0. The slope is 2, which is 2 over 1. So for every 2 I go up, I'm going to go right 1. 2 more up and right 1, so I'm crossing over here. And then for every 2 down I'm going to the left 1. Okay, now here you can see the line is above the parabola between where they intersect, but that's not what we're asked for. We're asked to look at x equal -2 and x equal to 3. X equal -2 is over here. And x equal to 3 is somewhere on the right. Let's find this intersection point first. The intersection of these two would be x squared minus x equal to 2x, or x squared minus 3x equal to 0. So that means x times x minus 3 is 0. They intersect at x equals 0 and x equals 3. This point is the point where they're intersecting. So this is x equals 3. So if we're looking between the lines x equal -2 and x equals 3, let's see what area we're referring to. What's bound between the two functions would be this part over here, and between 0 and 3, the part that's bound would be this part here. It's got to be enclosed by the functions and those vertical lines, x equal -2 and x equal 3. So now we've got two different pieces. If you have it as two different pieces, you need to think about needing two different integrals. Because look at the first piece here. Between -2 and 0, which function is the largest? If you just dropped a straight vertical line, it's passing through the parabola first. The parabola is greater than the line down here. So the first integral, when we set it up, we'll have the parabola's equation first, x squared minus x minus the 2x. And that one, what x's is that part of the area bound between? It'd be -2 to 0. And then we're going to have another part of the area between where the x is 0 and 3. Which function is the greatest? If you look at just a line going straight up and down between 0 and 3, it's hitting the line first. So we're going to have 2x minus the x squared minus x. Now notice I put parentheses here, but I didn't in the first one. That's because the second one has two terms. So I need to make sure I subtract them both. So now simplifying first, this was going to be x squared minus 3x from -2 to 0. And then the other part of the area is going to be from 0 to 3. We're going to have 2x minus x squared, and then we'll have another plus x, so we'll have 3x minus x squared. Okay? So now finding the antiderivative, we're going to have x cubed over 3 minus 3x squared over 2. That one goes from -2 to 0. And then we'll have 3x squared over 2 minus x cubed over 3 from 0 to 3. Okay, the first one down here. When you put the 0 in to both of these terms, you're going to get 0. And then minus what you get when you put the -2 in. Put the -2 in, I have -8/3. -2 squared is +4, but then I'm going to be subtracting it times that -3, so that's going to be a -12 divided by 2, so that's -6. And now for the second integral, I'm going to put my 3 in first, so I'm going to have 3 times 3 squared, so it's going to be 27/2, and then minus the 3 cubed is 27/3, which is 9. And then when I put the 0 in, I'll be subtracting 0 from both of those. So now this first one, let me go ahead and get a common denominator, since there's not going to be terms across the two different integrals that have the same denominator. The common denominator here in this first one will be 6. So I'm going to write this as it's 3, so it'll be 18/3 for that minus 6. So I have -8/3 minus 18/3, so that's -26/3, but then this minus in front of all of that makes it positive. So we're going to have 26/3. And then the second one, I'm going to have 27/2 minus 18/2, which is just going to be 9/2. And that's a positive value, so plus a 9/2. Notice each one separately is a positive area. By doing the largest minus the smallest, we're going to keep those positive. So you should always get each one separately positive. And now my common denominator will be 6 here. So I'm going to have 52 plus 27. So I'm going to have 79/6 for the total area.